All right. So it sounds like we wanted to see a few examples from section 6.1. So these are actually just going to be some problems, not problems that you are assigned for homework, but problems out of those homework sections and areas. So I just wanted to go through a few of these 6.1 problems, and then we can talk about 6.2 a little bit more in class on Wednesday. But real quick, let's just look at, there's actually two problems that were not assigned, but they're very similar, and it helps kind of bring back some of the notes that you received. First is basically find y without a calculator if it's the inverse sine of the square root of 2 over 2. And this is the way it's written. And so that's very similar to number 26, which is also finding the arc sine, which again, so just a reminder, arc sine and inverse sine are the exact same thing. And in this case, the value is negative root 2 over 2. Okay? And it actually says to do this without a calculator. So really, what we need to know is what angle gives us the square root of 2 over 2. Okay? And we can use the unit circle. We can use a hand trick. So the hand trick would say, well, sine of our angle, so sine of, in this case, y, is the square root of 2 over 2. And it would say the sine, in this case of this y, is negative square root of 2 over 2. All right? And so sine, if we just pull out our hand trick, sine is the values below our angle. So when there's going to be 1, 2 inside our square root, that's our angle, right? And our hand trick says that when we hold down our middle finger, this is your over 6 over 4, so we are at pi over 4 is what our y is going to be. Now, that begs the question, and kind of brings back the notes that we were given about whether these are positive or negative. Pi over 4. Because again, over 4 is going to give us a negative root 2 over 2 as well. It's just a matter of where does it fit? Do we need to add a 3 pi over 4? Or a 5 pi over 4? Or a negative to the pi over 4? And so the whole point that I'm making now is that in the notes it said that the inverse functions are only defined for sine when y is in between negative pi over 2 and pi over 2. Does that make sense? So for arc sine of y must be in this interval. Okay? So we can actually draw the interval and say, look, there's negative pi over 2 for your angle. There's pi over 2 for the angle. And so if this is going to be a pi over 4, a positive pi over 4 to get a positive sign, it's got to be right there in that quadrant. So we know it's positive pi over 4. That's your answer. Okay? In order to get a negative sign, it's going to have to be down here. So in order to fit in this interval, it's going to have to be a negative pi over 4 to get down there. So we know that we're going to have a negative pi over 4 for the inverse sine of negative root 2 over 2. All right? So we need to know what these restrictions are for the inverse functions. Okay? So we have a positive pi over 4 and a negative pi over 4 in these two similar problems. Okay? So I wanted to do them both to kind of show you the difference. Now, we can move on and let's take a look at number 74. Number 74 says to give the exact value without using a calculator of what we have here is the cosecant of the inverse cosecant of the square root of 2. Right? And when we see this, what we should first say to ourselves is, this is similar. This is a similar idea to saying x divided by 2 times 2 is just x. I mean, these are inverse operations. So if you take the inverse cosecant of something, it's going to give you an angle, and then taking that angle into the cosecant is going to get you right back to the square root of 2. So we should know that this is the square root of 2 because we have an inverse. These two are inverses of each other. Okay. So how we will go about doing this type of problem and others that are not this straightforward are we're going to use substitution. So if we say let u equal the inverse cosine of the square root, or sorry, not cosine, but cosecant. If u is the inverse cosecant of the the square root of 2, then the cosecant of u is the square root of 2. Okay? Using a reciprocal tells me that the sine of u, which is the reciprocal of cosecant, is just going to be 1 over the square root of 2. So if I go from cosecant to sine, I just have to find the reciprocal of that, which then simplifies to the square root of 2 over 2. And I can now draw a right triangle for my angle u. And for sine, it's opposite over hypotenuse, so that tells me that the opposite side of u is the square root of 2, hypotenuse is 2, and now we just need to find what this is. So Pythagorean theorem would tell you that that's the square root of 2. All right, and that is also true because of this idea of inverse. The inverse cosecant is similar to the inverse sine, where you're going to be in this quadrant when you're positive, right? And so really what we needed to find is we can use this triangle to now say, all right, well, the sine of u equals, well, root 2 over 2, right? And so then coming back full circle, what we really needed to find, since u is this, we can substitute that in. We've been looking for the cosecant of u from all the way back here. Does that make sense? So u is this. We really wanted to find the cosecant of u. We've created the triangle that allows us to do that, and we know what the sine is. And so the cosecant of u is just the reciprocal of that, which is going to be the square root of 2. 2 over the square root of 2, rationalize, and you get the square root of 2. All right. So, you know, this is a redundant process here, really, because we know what the cosecant of u already is right here, right? But you go through these steps, and that allows you to find any, when you have any combination of functions here, it allows you to solve this. All right. Better. So, again, sorry, you might not have been able to see all that, but, this is just the steps. Again, substitute for inside. It allows you to then rewrite this inverse as a function, as a non-inverse trig function, right? Which then allows you to draw a right triangle. And again, because this is positive, you're going to be in quadrant 1, right? So we're right here, drawing your right triangle. So then if I'm looking for, let's say I wanted to find, instead of cosecant u, if I wanted to find the tangent of u, well, you can use this triangle to find your tangent or cotangent or cosine, any other trig function. All right. The last type of problem then that was on this 6-1 assignment, these are all similar to what your notes are on as well, but the last one would say something like 86, which was write this as a algebraic expression, which means don't say that this equals something with a trig function in it. So it gives us the cotangent of the arcsine of u. And we need to use a similar process that we just did, and we can use any other variable in our substitution. So, but if we said let x equal the arcsine of u, then the sine of x would be u, and it'd be u over 1, right? And so we can draw a triangle for x, because again, that's your angle. X is your angle here. Sine of x is u over 1, opposite over hypotenuse. And then we can just use the Pythagorean theorem to say, well, u squared plus, let's call that a, u squared plus a squared equals 1 squared, right? And we need to find a because the cotangent of the arcsine of u is actually equal to the cotangent of x. So we can find the cotangent of x by finding what that side is in relation to u. Okay? So a squared equals 1 minus u squared, square root it. A is going to be 1 minus u squared. And it's positive, not plus or minus, but positive because our directions say that u is greater than 0. So if u is greater than 0, it's going to be in quadrant 1 if you're taking the arcsine of u. So they're all going to be quadrant 1 angles on these types of problems. So a is actually this, right? And again, we use substitution because it allows us to say the cotangent of x is what we're actually looking for. It's what we're trying to find. So the cotangent of this angle x now is adjacent over opposite, right? That's cotangent. So the adjacent is a, which is the square root of 1 minus u squared. And the opposite is u, which is that. So what we've been able to show is that the cotangent of the arcsine of u can be written as the square root of 1 minus u squared over u. Okay. And so that's what you're being asked to do when you're being asked to write as an algebraic expression.